Hello, this is the lecture number 8 for the chapter Continuity and Differentiability for class 12th, and in the last lecture we have discussed up to exercise 5.3. Now to have a good understanding of this lecture, you should at least see that lectures before doing this. Now in the 5.4 we have the very simple exercise in which we have the quotient rule or the derivative of composite functions. So see the question number 1 of exercise 5.4. You have to differentiate e raised to power x upon sine x. So you have to use the quotient rule. Square of the denominator, derivative of the numerator minus numerator, derivative of the denominator. This is the simple quotient rule. We have to use it here. Now the derivative of e raised to power x is e raised to power x, and derivative of sine x is equal to cos x. So the simple derivative of e ki power x upon sine x. Now in the question number 2, we have e raised to power sine inverse x. It is a composite function. First of all, we differentiate e exponential, then we multiply with the derivative of sine inverse x. Now what is the derivative of e raised to power x? E raised to power x ka derivative e raised to power as it is. Now multiply with the derivative of sine inverse x. First of all, differentiate exponential, then multiply with the derivative of sine inverse x. So derivative of exponential is exponential as it is, and multiply with the derivative of sine inverse x, which is equal to 1 upon under root 1 minus x square. So simple composite function is this. Again, we have the composite function as in question number 2, exponential and x cube. First of all, differentiate exponential and multiply with the derivative of x cube. So the derivative of exponential function is exponential function as it is, and multiply with derivative of x cube. And the derivative of x cube is, you know it is 3x square. Now see this very carefully, because in this we have how many functions? Sine, tan inverse, e raised to power x, and minus x. We have 4 functions, so you have to differentiate in 4 steps. So first of all, we will differentiate sine, then we differentiate tan inverse, then we differentiate e raised to power minus x, then we differentiate minus x. So first of all, differentiation of sine, it is cos, and the remaining function as it is. First of all, differentiate sine, which is cos, and this as it is. Multiply with the derivative of remaining 3, tan inverse e raised to power x. Now we'll differentiate e raised to power x. So the derivative of e raised to power x is 1 upon 1 plus x square. So in place of x we have e raised to power minus x. In place of x we have e raised to power minus x. Now multiply with the derivative of e raised to power minus x. Now derivative of e raised to power minus x is e raised to power minus x, and the derivative of minus x is minus 1. So first of all, we have differentiated cos, then we have differentiated tan inverse, then we have differentiated e raised to power minus x, whose derivative is e raised to power minus x, multiply with the derivative of this, that is minus x, that is minus 1. So it is a good question. Cos, tan inverse, then differentiate e raised to power minus x. Now in question number 5, derivative of log cos e raised to power x. So we have 3 functions here, log cos x, cos e ki power x. So first of all, differentiate log, then multiply with the derivative of cos, then multiply with the derivative of e raised to power x. E raised to power x. So 1 upon cos e raised to power x. Derivative of log is 1 upon this. Derivative of log is 1 upon x. This. Multiply with the derivative of cos e raised to power x. Cos e raised to power x. Now differentiate it. Cos, it will be equal to minus sine e raised to power x, and multiply with the derivative of e raised to power x, which is equal to e raised to power x. Sine upon cos, it's tan. So sine e ki power x upon cos e ki power x will be equal to tan e ki power x. Minus sign will be there because derivative of cos is minus. So it is a composite function. Question number 6, e raised to power x plus e raised to power x square and so on up to e raised to power x power 5. You have to simply differentiate individually. E raised to power x derivative is e raised to power x. E raised to power x square derivative is e raised to power x square multiply by the derivative of x square, 2x. First of all, differentiate exponential e raised to power x square multiply with the derivative of x square, which is equal to 2x, and so on. And the last term will be exponential derivative e raised to power x power 5 multiply with the derivative of x to the power 5, which is equal to 5x to the power 4. Now in question number 7, we have three functions: root, exponential and its power. So first of all, we differentiate this root, then exponential, then this root x. This is a composite function. So first of all, derivative of root 1 upon 2 root x. Derivative of root x is 1 upon 2 root x. In place of x, we have e raised to power root x. Multiply with the derivative of e raised to power root x. Now differentiate, because we have differentiated this. Now multiply with the derivative of this, e raised to power root x. Now the derivative of e raised to power x is e raised to power as it is, multiply with the derivative of root x, which is equal to 1 upon 2 root x. E raised to power x derivative e raised to power x, multiply with the derivative of root x, that is 1 upon 2 root x. Question number 8, derivative of log x. It is a composite function of log with log x. So first of all, differentiate this log. Derivative of log is 1 upon x. So in place of x, we have log x. So 1 upon log x. First of all, differentiate this log 1 upon log x. Multiply with the derivative of log x, which is 1 upon x. Composite function of log and log x. First of all, differentiate log, which is equal to 1 upon log x. Multiply with the derivative of log x, which is equal to 1 upon x. And we are doing it by direct method. Now question number 9 is very easy. It is a derivative by taking the quotient rule. Square of the denominator, derivative of the numerator, minus numerator, derivative of the denominator. Derivative of cos x is minus sin x, derivative of log x is 1 upon x. It is a simple question. In question number 10, we have cos in the bracket log x plus e raised to power x. So this is the again composite function. First of all, differentiate cos and multiply with the derivative of this bracket. So derivative of cos is minus sine, bracket as it is, multiply with the derivative of this bracket, which is log x plus e raised to power x, and the derivative of this bracket is 1 upon x, and e raised to power x is e raised to power x. So in this exercise, we have done the derivative of composite functions of various types. Either it is a product rule or a quotient rule. We have used it here, and in most of the question we have used the derivative of the composite functions. Now after this, we have the very important exercise, and most probably you'll get a question in your boards. Differentiate by taking logs. So before doing this, you must know the properties of log. So I've written it here, properties of logs. Log m into n. In multiplication becomes, in breaking, log m plus log n. Log m into n is equal to log m plus log n. Multiplication becomes plus by breaking the log. In division, log m upon n, it becomes log m minus log n. In division, it becomes minus. Log m raised to power n, the power get multiplied with the log. N log m is the removing of the power. Now this is property of log is known as changing of base. Log b of base a. Log b of base a. So log b upon log a. The base of this becomes same, that is e. When we don't have the base of the log, it means it is base is e. This is known as the breaking of the base. Log b upon log a. Log b upon log a. Breaking the limit. E raised to power x is equal to x. You must know this property because in one or two things we have in one or two questions we have to use this property. So these are the properties of log: multiplication property, division, power, and changing of base. For example, if you have to find the derivative of e raised to log of base x of log 10. Now we know the derivative of log x of base e. Now first of all, how can you do it? We first of all break it by breaking the base. This is like this. Log x upon log 10, like this. This property you have used, log b upon log a, log b upon log a, log x upon log 10. Now you can differentiate. 1 upon log 10 is scalar here, and the derivative of log x is 1 upon x. This is known as differentiate by breaking the base, or breaking the base property of logarithms. We must know it. So where we can use the properties of log and find its derivative? When the calculation is very, very difficult. Then we have the product of these three. You have to find the derivative of this. this complicated expression under root the quotient of these 5 functions. You can do it directly, but by taking logs, it become very easy. You can differentiate this function again without taking the log also, but by using the product rule, but by using the log, the differentiation of this question become easy. So, and where we have to use logs, when the base as well as the exponentials are in variables. For example, x raised to power x derivative, because base x and the power is also x, both are variables. Or you have to find the derivative of y raised to power x. The base as well as the exponents, both are the variables. So in that case, we have to differentiate by taking the logs. But in these types of questions, we have the product or this. We can solve it or differentiate it without taking the log also. But by taking the log, the derivative become easy. Now, I'll discuss the exercise 5.5 in the next lecture. Thank you.